All right, guys, we're going to review FRQ 2023 number 4. So the question I have here, and then I'm going to go over my answers as well as the scoring rubric for this question. So in part A, it is asking, using the graph, does f have a relative minimum, relative maximum, or neither at x equals 6? And to give a reason for our answer. Now, since we're looking at the graph of f prime, what we are essentially looking for here are places where the function, actually, I'm sorry, we're only looking at x equals 6. So at x equals 6, it looks like that f prime is equal to 0, which does make it a critical number, but what you will notice here is that it's positive to the left as well as positive to the right. So it's going to be really important in terms of how we're going to write this answer out. So what I have listed here for the points, for A, it's just a one-pointer, is that f has neither a relative max or min at x equals 6. While f prime of 6 is 0, f prime does not change from positive to negative or vice versa at this value. You need to specifically reference everything in terms of f prime with this question because that's the function we've been given. Any interpretations, and we'll see this later on, that you make about f or f double prime or anything like that will not be able to, well, count for this in terms of being scored. And so I just want you to note here with this question, all you really have to do is essentially note that it's positive and positive on either side and that it does not change sign. And notice everything is referencing f prime specifically. Okay, in part B, let's bring the question back. On what open intervals, if any, is the graph of f concave down? So this is what I was just meaning a moment ago. So that means we're going to look for when the second derivative is negative. Since we're given the graph of f prime, f double prime is noted as the slope of f prime. And that, what I just said there, is what we have to make sure we use as our language. We're not going to refer to it as f double prime. We're going to refer to it as the slope of f prime. So there are two instances I see here where the slope of f prime is negative, from negative 2 to 0, and then again from 4 to 6. So when I write my explanation here, notice the importance here. F is concave down on the interval, so the actual interval that's provided is going to be your second point. But then, as I mentioned before, look at what I'm saying here. F prime is decreasing. You could also say the slope of f prime is negative. But if you said the reason why this is concave down is because f double prime is negative, you would not receive point number 3. And just to give you the scoring rubric here so that you note, to earn the second point, a response must correctly discuss the behavior of f prime or the slopes of f prime. So that's going to be very specific on that second point. Okay, let's go ahead to part C. Part C is finding the value of the limit here, which is going to be your classic L'Hopital's rule question. So let's go ahead and discuss what we have to make sure we do here, and this was emphasized a lot last semester. In order to receive the first point for L'Hopital's rule, you need to show that separately that the numerator is approaching 0 and the denominator is approaching 0. And I'm going to go right ahead and just acknowledge to you that if you write anything of an indeterminate form, 0 over 0, oops, actually you cannot say it equals 0 over 0 there. So you can say is of indeterminate form like this, but a response that presents a limit explicitly equal to 0 over 0 does not earn the first point. So really, really important, and we've talked about that a lot. So I wrote a little blurb that says, okay, indeterminate form, L'Hopital's can be applied. The actual L'Hopital's rule process of writing the new limit would be your fifth point, and then any of these numerical evaluations, whether it be this first form, this unsimplified fraction, or this 3, that would earn you 0.6. And I'll just go ahead and note here a few other, let's go back over here for part C, just to note any other important things here. Again, first point is earned by the presentation of two separate limits for the numerator and denominator. And then correct answer. Okay, that's all we have there for that problem. Okay, I think we are on to part D, the final part of this question. Part D says find the absolute minimum value of f on the closed interval -2 to 8. Okay, so this is candidates test. So we need to figure out when f prime is equal to 0. Those are going to be my candidates. Or when we have, when it's equal to 0, I'm sorry. -1, +2, +6. Those are going to be my 3 candidates, and then the additional candidates that must be considered are going to be -2, +8. Now, it's really, really important. in this problem, to earn your first point here, which is 0.7, you can't just say f has critical values at x equals -1, +2, and +6. You need to state how and why you got these. So you can't just call it critical values, you need to give a specific reason. So what we primarily want to write here is just noting that you're looking for when f prime is equal to 0. So probably a faster way to say this is f prime equals 0 at -1, +2, +6, and that'd be suffice for 0.7. 0.8 is going to be earned by actually evaluating and looking at all of your candidates and taking this and plugging it in. All of these values are found by looking at the integral that I have listed right here off to the right hand side. And this is really crucial for this problem because in order to evaluate f, we would have to integrate. And the reason I made my lower limit of integration 2, very important here, is because we were given that initial condition right here of f of 2 equals 1. So as soon as I saw that, I knew that I needed my lower limit of integration to be 2 so that I could set up my fundamental theorem of calculus here. Just a reminder that this right here is equal to f of x minus f of 0, and I just kind of move things around to write it in terms of f of x. So now that I have this f of x here, I now can plug in -2 as my upper limit, -1, +2, which again is just 1, +6 and +8. The note for 6 and 8 is we have a semicircle here, but it is a semicircle with the semicircle removed. So you have to find the area of the rectangle and then remove either the quarter circle or the semicircle depending on the situation that you're trying to find here for x equals 6 or x equals 8. And then your final point is just identifying of these 5 candidates that the minimum value here is 1 and that occurs at x equals 2. And here is the scoring rubric. So you can see again, here's where all of those 3 points are coming from. And then here are some scoring notes for specific situations if you would like to look for your particular problem.